Hi, this is Jeff Spence, your Math 120 instructor for the Community College of Denver, and this is the second video over percent applications. And these problems are a little bit more difficult, so I've kind of put in a description here. These are specific percent applications in which percent increase or decrease has been applied, and we know the final result after that percent increase or decrease. So there's a couple things we need to be aware of. That the main thing is that we know the result of the percent application. So we're still going to be using the percent application formula where we're going to be given the percent, like as you can see in both of these examples, we'll be given a percent. But the difference about this percent is that it's a percent increase or decrease, which makes these problems a little bit harder. And then the other thing in common that both of these problems have is that we know the final result, which is going to go on the right. So we're not just taking, like, when we look at this problem here, after a 15% off sale, an item costs $134.23. We're not just taking 15% of $134.23. We're not just doing 0.15 times $134.23. What we have to understand is that a 15% off sale, 15% off, is not the same thing as 15% of. 15% of is 0.15 times something. But 15% off, that's the same thing as taking 15% off of 100%. So for instance, 15% off of the original price means 100 minus 15, which equals 85% of the original price. And we know that after we take 15% off, which means that we're actually taking 85% of the original price, the item costs $134.23. Okay, so the thing is when we use the percent application formula, percent in decimal form times the total or the original, we convert the percent to a decimal and we multiply. So 85% of something means to take 0.85, 0.85 times something. But the thing is we don't know the original price. So we call that X. But we do know the result is $134.23. So when we're in this situation, there's two things that happen. First, 15% off is a 15% reduction, a 15% decrease. So we have to understand that we have to convert that to a percent of the original. So we had to subtract that from 100. Excuse me. And then we had to understand that we're not taking 85% or 15% of this 134.23 because that's the result of the percent change. Once we have this set up, then it's just algebra, understanding that when you have a number times x equals another number, to solve for x, you just divide both sides by 0.85. So ultimately x is going to be 134.23 divided by 0.85 to get us our answer. So we do 134.23 divided by 0.85. Make sure we round to the nearest cent because this is a money answer. So rounding to the nearest cent, as you can see, the 7 is going to round that up to 92 cents. So I'd say this is $157.92. Okay, so then the next one's similar, but it's going to be a tax rate problem. So we'll see how that changes the situation, or how we change our approach. So this one says an item costs $35.87 after tax. The tax rate is 7.8%. What is the price of the item before tax? So we know the price after tax, which is the final result after a percent tax has been applied. So that's going to be the value on the right. The thing is, though, tax is a percent that's added on to the 100% cost that you're going to pay. So when you see a price tag, you have to pay 100% of that cost plus the percent of the tax. So whenever we have tax, tax is just added on, as opposed to the sale where it's taken off. So here the tax rate, we're going to pay 100% of the price tag plus 7.8%. And that's going to be 107.8% total percent of the original price that we're going to pay because that 7.8% was added on. So to convert that to a decimal, so let me write that in this form, 107.8% of original price equals price after tax, which is the 35.87. So we convert, once again, now I have it in the form of a percent of something that I don't know. So I just do, sorry for my slow getting mouse over there, or indicator over there, 107.8%. I got to convert that to a decimal, so I move this decimal spot 2 spots to the left, 1.078. Sorry about that, a little slow here, times the original price, which we do not know, call that X, gives us the 35.87. So the big difference here is that the 7.8% was added on, versus over here, the 15% was taken off. Either way, we understand that increase or decrease, we add it or subtract it from 100, we convert that to a decimal, and then that's times X to get the result. So now we're just dividing. So I'm doing X is 35.87 divided by 1.078 to get, let me pause here, 35, oops, sorry, I didn't type that right, 35.87 divided by 1.078. Once again, this is money, so I need to round to the nearest cent. So I look to the 7, to the 4, to the right. It says that I keep it the same, so $33.27. $33.27 would be the final answer. And I could actually check that by doing 33.27 times 0.078. That would be the tax, which would be $2.60. So $2.60 plus 33.27 gives me the price of $35.87. Okay, that's it. We'll see you next time.